We're recording.
Chadwick.
Okay, so let's talk about some other stuff, right? I want to go through this. If I'm a little bit slow, I'm sorry. I'm sorry. Yesterday, I walked into a bar, and it hurt. It was metal.
Once I read it,
Bar, guys. It's a metal bar.
once I did that, and I almost broke my nose.
Oh, I get it now.
All right, there it is. It takes some time. Let it simmer. All right, so listen, we're going to go through this. I'm going to try to get through some of these real quickly, and then we're going to talk about some in more detail. Binary and hexadecimal, I'm going to talk about quickly. We don't need to spend a lot of time on this. If you have questions, ask them. Just don't go too deep down the rabbit hole, because we certainly could, okay? All right, so if we go back, let's go up to the top. Let's see what we do. Hexadecimal, or binary, right? So if we look at this, talk me through the difference of the two, hexadecimal and binary.
Binary is base 2 system, and then hexadecimal is base 16.
Okay, right, exactly, right? And so when we look at those things, those are two sort of components that are used to easily codify information, right? So ones and zeros, remember with binary, everything about a computer, when you get down to its core, is a 1 or a 0, right? Everything. Numbers, letters, symbols, right? Cat videos on YouTube. Everything is a series of 1s and 0s, right? All right. So if we do that, if we look at this, let's walk through and count this up, right? So let's look at how we're going to count this, because one of the things I will ask you to do is to count, okay? To be able to count in binary, okay? At least up to 256, or 255 rather. All right. So if we look at this. And we're counting, this is the way the numbers are created, right? So you need to know the columns, correct? So you have 1, 2, 4, so each time it's going to be times the base for the next value of the next column, correct? Are you with me? Yeah. 1, 2, 4, 8, 16, 32, 64, 128. Here's the huge benefit. We're going to erase this for now because we don't need to talk about it. Here's the huge benefit about binary, right? You don't have groups, right? You only have the value or you don't have any multiplication to do when you're trying to figure out the values, right? So if I have 2 in the tens column, decimal, if I have a 2 in the tens column, what do I have to do to figure out how many that is? In a decimal system, in the system we use every day, if I have a 2 in the tens column, what is that? 20, right? It is 2 groups of that value, correct? That column's value. We're lucky with this because you can only have one group. So all you really have to do is count the column's values, right? Yeah. Okay? So if I have, let's go back, if I get rid of these, right? And I have, let's see. Well, come up and count to 40. Or show me right 40 in binary. Ooh. Right? Okay, good. Now, the only thing that we need to do extra, because this is a set digit, right? You need to fill in the others, right? Okay?
But what if this is the one with the sign? Is this sign?
No, this wouldn't be signed.
Okay.
Okay? Does that make sense? Did that just click for you? Is that nice? Okay, good.
Are we gonna have to?
Right? So, come on, Jordan.
Are we gonna have to do a sign thing on the?
Yeah. I mean, I'll talk to you about the value, right? But, okay. So you can do it that way. Yeah, that works. You can do it with your finger too. Okay. All right. So count. Somebody give her a number beneath 255.
253.
Wait. Let me. You pick somebody. Give you a number. So you know it's going to be above 128, right? So what's the nearest number that you can find on the board? 128. So you know that's going to be 1, right?
I'm not good at math. I don't like adding numbers.
Right, so what do we have left?
32, 64. I think you give me a low number.
All right, give her an easier number so we can figure it out.
4.
Not 4. Yeah, we can do 12.
21.
21.
Yeah, do 21.
Alright.
1.
Right? And then zeros and the other spots. Okay, you get it? Okay, does that help? Good. Well done, Jordan.
What?
All right. What do you want? What are you asking?
So can you have like a 1 and a 1 next to each other?
Sure. Right? So if I did this way, what was this? 21? Let's say I want to do 23. Right? And all I'm doing is adding these up, right? 16 plus 4 is 20, plus 2 is 22, plus 1 is 23. Right?
Yeah.
You okay? You got it? Mind blowing, isn't it? Okay. Questions about this, about binary? Let's touch hexadecimal for just a second. If we're looking at hexadecimal, right? This is a little bit more complicated because you do have groups, correct? And it's gonna throw you because you're gonna think that an F is an F, but in hexadecimal an F is a 15, an A is a 10, right? So it's literally gonna be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, right? Okay? So, what would it be if I said A, F? What number is that? What? So remember we're doing it by 16. So the second column, the first column is 1s, the second column is 16. So it is A groups of 16. A is 10, 160 plus 15.
175.
175.
Wait, what was that? Yeah, can you go with that?
So I'm going to convert this, right? So this will be 10, 11, 12, 13, 14, 15, correct?
Yeah.
Okay. So an A is how many groups of 16? Because it's the 16 column, right? So it's 10. So this 16 10 times is 160. So this is 160. And then what do we add to it here? What's the value of F? 15. Add them together.
What do you mean when it's the 16th column?
Yeah, why is it 16 times 4?
Okay. A base 10 system, right, is going to have, means that we're going to group in tens, right? So you get 10 things together, right? So you have 9 opportunities, or 10 digits, and then you go to the next column, right? 0 through 9, correct? And then a 10 is just one group of 10, right? And then 20 is two groups of 10, right? Well, the only reason that we have a decimal system, there's no like inherent value to it other than so many fingers we have, right? So we think in terms of 10. But I'm going to do the same thing here. I'm going to have the ones columns, right? Because there's no grouping. It's just a single unit. But I'm going to group in groups of 16. So then when I go to this column, I'm no longer talking about individuals. I'm talking about groups of 16, right?
Oh, it's like the tens column.
Yeah, that's exactly what it is, right? It just goes to more numbers, right? And then the next column would be 256. The 16 times 16.
Oh,
256.
if there's like a letter before AF.
Like there was one here,
Yeah.
right?
That would be.
Yeah, then this would. So if I did one here, it would be 256 plus 175.
So if you did like 11 times 256.
Exactly. So if I did this, let's do it. So if I did B, right? That's going to be 11. So what is 16 times 11?
176. Yeah, that.
plus 15,
Okay, 191.
right? So this would be 191. Okay? Now, I'm not going to ask you, yeah, or, oh, was there a question?
No. I get it.
You get it?
Yeah.
Okay. So this stuff is hard, right? Hexadecimal is, for whatever reason, it's harder to get. But like once you get it, it's there. Like you can do a base 8, right? Or a base 4, or whatever. Right? Do what?
Would the F be 201?
It would be 256.
Oh, whoops.
No. Sorry. I'm lying. So it would be, what was 16 times?
Oh,
176 plus 15.
191.
Okay? Y'all follow how that works?
Yeah.
The next
Okay.
column over would be 256 times 16, right? That would be the next.
Yeah, exactly. What's the next column?
A big.
What's 256 times 16?
Big boy number.
You have a calculator, right? If you're on Google, you've got a calculator.
4,096.
Right? That's a lot, right?
It's a lot.
So, all right, does this make sense? Does the system make sense? Feel comfortable with it? All right. So let's move on. Let's look now at. So let's look at this. So we've got binary, hexadecimal, right? That's all I want y'all to see. Now we need procedural code. Let's look at procedural code in OOP. I'm going to show y'all some of the same slides that I did in the other class just because I don't want to type it all again. I'll write it all again. So let's think about this, right? So first, let's look at the procedural code over here. Now, if I was going to write a program for like Home Access Center, okay, or that's sort of connected with that, I want you to think about the way that works, right? So if you think about a student experience, the student logs on, they see their class, they can go do, like they can sort of jump to this line or jump to that line or whatever. It's pretty limited in what they do. It's very procedural. Like I'm going to start, student logs in, then they're going to do this, and they're going to do this, and they're going to do this, right? So think about the student experience from beginning to end, okay? But then we also need to write one for the teacher, correct? Because I need to think about like what I do. So then if I do that, and I think, okay, I've got 3 AP computer science courses and 1 English class. So if I have those, then that means that I've got, so I need to know the scores for those. And so that's all programmed in, right? But it's thinking about the teacher perspective, which is fine, right? You can absolutely do that. But then you've got to write it for the student, then you've got to write it for the teacher. You've got to have it all sort of put together, right? Which is fine. But if I introduce something else, right? So like if we come over here and all of a sudden I say, you know what I really want? I really want this program to be able to manage clubs, like student engagement clubs. Right? So if I want to do this in clubs, then then all of a sudden I'm like, great. And now I have to rewrite everything. Because now the experience is different. I've got to add that in, and I've got to be able to interact with them, right? So that's tough. What if I say, oh, you know what? I want to have 2 teachers for every class, not just 1. I want it to be, to be able to have 2 teachers in a classroom setting. Now I got to go back and I got to start from scratch and figure that out, right? So object-oriented programming gives us the capacity where I can say, here's my school, which is an object, right? Or it is an idea of a thing, right? So I have a school, and then in that school I have different objects. I have students, I have courses, I have teachers, I have clubs, right? I have all of those things. So I could have this where, if there wasn't a club yet, right, if we hadn't been asked for that, I can write this program. And these interact with each other. How hard would it be now if I said, you know what, I don't just want 1 owner of a course, I want to be able to have 2. That's a whole lot easier than rewriting everything. I just needed to add a new variable to this class that says second teacher, right? And then I can build that out. Yeah.
So in that example, what would be the class? Are they all just objects?
Okay, so and I'm talking about object-oriented programming. All of these would be okay. So remember, a class is a specific type. It's a specialized object, right?
Yeah.
So like string is an object. System, remember yesterday when we typed system.out.println? System is an object. You never see. It's in the background. I mean, you can refer to it, but you don't need to see it, right? So those things sort of exist. So objects are bigger than that. But in this context, school would be a class, course would be a class, student would be a class, teacher would be a class, right? And then clubs, if we added clubs back in. Now, I do want to also point out, it is absolutely fine to have variables of a particular class in another class. We have a bike. Fair to say that's an object? Fair to say it's a classification? It's maybe a type of vehicle or whatever. Are wheels also an object?
Yeah.
Could be, right? So if I think about a school, right? A school is an object, right? It's a classification of a thing, right? What's it made up of? Students, which is the classification of a thing. Teachers, classification of a thing, right? So all of those things are part of it. So you have this sort of idea of object-oriented programming takes an object, or takes objects, and then has them interact with each other. But by defining them with clarity, then you're able to follow through, right? You're able to then very easily keep track and manage complexity, right? Remember, we talked about that at the top right. You want to be able to maximize efficiency and minimize complexity, and that's it happen. Now here's what's confusing. When you first look at this, it gets a little scary, right? You're like, what? That's a lot of arrows, right? And so it looks more confusing to begin with. But then once you start writing it, then you realize, okay, that's actually fairly manageable. I can connect these things. It's easy. Yeah.
So teacher would be a class, and then Mr. Ken would be an instance.
Very good. Yes, exactly. Exactly. Right? Okay? And then same for y'all. Y'all are all different instances of a student class, correct? And you're all independent. So, if Emma takes the class, it's only on her, right? It's not a shared grade. Sometimes I wish there were shared grades. I think the peer pressure would be just awesome. Hey, guess what you're doing tonight? All right, so does this sort of make sense as a concept? Yeah? Okay. All right, so let's look more specifically. So let's talk about the class, right? About what a class is. Hey, are we all focusing? You can't sit right in front of me and whisper. All right, so let's sort of get an idea of this, right? So a class, remember that this is not as simple as we'd like it to be. That sometimes these things can be a little bit confusing, right? So a class is more than just an idea. That's one way to define it, right? It's an idea of something. So we have the idea of a student. We know, sort of what a student should be. They have, shared characteristics and all of that. But it's also to keep in mind, it's also important to keep in mind that it is also the blueprint. So a class is literally a set of instructions that is going to tell you how to build that thing, an instance of the thing, and how it acts. So in this case, how do I build a student, and what can a student do, right? What actions will it take, right? And then we're going to define those in code. So for instance, we have variable names for the class. We have name, ID, grade, GPA, and pick, right? All of those things are values for it, or variables, right? So an instance variable. Those are all dependent on the individual, right? The instance of that classification. They belong to a specific student. Notice that the variables are nouns, right? So what are the methods? Actions or verbs. Okay? You with me? So I have public class student, right? This is the way we define a class. This you need to know. So you need to know how you're going to define a student, how you're going to define a class, and how you're going to define a constructor, and how you're going to define a method. Those are three things that you need to know, right? Definitely. So I have public, class, and then the name of the class. Remember, you are making up the names of the classes, right? Or they're You're reading somebody else's code. The name of the class was just decided on. Somebody just made that name up, right? Because it's the most close representation of it, okay? And then you're going to have the curly braces. Do you have parentheses on a class construction? No. And guys, this you just have to memorize. If I say write a class, call it, like build a framework of a class, call it student, you would need to be able to do public class, student, curly brace, right? Or if I said write a method, you would need, write a method called get grade, right? You would have to be able to go private, what's the return type, what's a grade going to be? So you would return it, right? Because I'm getting something from you. So private, probably a double, because there's going to be a decimal point, or there could be a decimal point, right? Private, double, the name of the class, right? Or name of the method. We're going to talk about that in a minute in more detail. All right, but I want to remind you how this works, right? So over here in school, right? I need to build a new student. I just had a new student come in, so I name current student. I build it, right? New student with the parentheses, so that's calling the constructor. It goes over to this class and it runs it, right? So it goes over to the student class, reads through the file and says, what do I need to do, right? What values does this thing have? What methods is it going to have so I can associate them with it, right? Let's put up our phones. I'm done with the phones. You don't have a phone? Are you sure? All right. God, I hate getting mad at y'all when I should. Just remind me next time you do something wrong that I've already been mad at you. All right. Okay, so I'm going to go through. I'm going to run through the class. Right? It's going to do those things. It's going to establish the methods, and then it's going to go and it's going to put it on the hard drive. Remember, this is the hard drive, right? Find the location in memory, and then you've got that instance is built, right? Okay. Yeah.
I'm so confused on what exactly the constructor is doing.
Okay. Let me see if I can. I'm going to give you two answers, right? The first answer is it is where you set all of the default values. Okay. You can't run code outside of a method, and sometimes when you first create an object or an instance, you need to interact with the computer. You need to go to the database, right? Maybe like before I can get your name, I really need to go to the database and get the information, then bring it back and then process it and then do all of that stuff. And you can't do that outside of a method. So you need to call a method as soon as you're started that instance, right? As soon as you build the instance.
So it's like a special type of method?
It is.
Okay.
Yep. That fires. It's the first thing that fires, right? So Java looks for a constructor. If it doesn't see it, it runs a default one behind the scenes. Okay. Now, here's the thing. That's the first answer, right? So that's the technical answer. The other answer is just use them. They're on the exam. Very little you're going to write at the beginning. Are you going to need a constructor for it? Still use them, right? Because if you don't, you won't get used to it, and then it's going to be confusing later on. Oh, and they're going to have them on the exam. Yeah.
So I don't really get where you're doing on the left side. So,
Okay.
Are you?
Can we kind of go through that again?
Yeah. Sorry.
No, that's don't. Why would you apologize? Ask me all those questions. Okay. All right. So let's do this. Let's pretend I'm not gonna write the whole thing up. So I've got my school over here, right? Actually, let's do it. Right? Public class student, right? This is where we're going to build the student out, right? Okay. And then over here, I'm already running a school class, right? So this is in school, and at some point in there, there's a method that says private void register, right? So this is when you're registering a new student, okay? And then I come in here, and then I'm going to say new, let's just do STU, keep it short, okay? So student equals, and I'm gonna do this right, even though I'm not worried about this for y'all yet, but you need to say what kind of data that's going to be. So I go student, right? So this is the kind of variable that I'm creating. STU equals new student. Okay. Now, what happens with this when I make this new student? I'm literally saying go out and build it. That's what that word means, right? Java knows you can't name anything new.
You're just like, I just look at why you're equaling like what's on the left to what's on the right.
Okay.
Just because it's.
Now, maybe later on I need to refer to the student, right? I need to register him for classes, right?
Yeah.
So I need to be able to talk about that student. I need to have a name, a temporary name for that student in this program, right? So like if this is the current student, I want to know like, so I'm going to create a new student, right? And then I'm going to say stu dot get name, right? So maybe now I'm going to define the name, right? Which I'm going to say, hey, what's your name? How old are you? Right? So all of a sudden I'm going to get a bunch of stuff from him. But this is the local variable name that I can refer to that student as. Because that contains the reference to the spot in memory. Yeah.
If you make like that private and then make another one that's private and name both of those students.
If they're in the same class, it would cause a problem.
But
But if you name one here that was that, and then named one the other, it is fine. Right? Yeah.
So then if you wanted to, wouldn't you need to make a constructor to actually define students somewhere?
That this is over here.
Okay.
Right?
You
So
don't
over
need-
here I would have public student. Notice that I don't have, right? And then stuff would happen in here.
So you define, I guess, a student name, and then would you need it to be public over there at school to interact, or because that?
This get name would have to be public.
Okay.
Okay? But listen, y'all are doing a great job of asking questions you don't need to ask yet for that kind of, like we're going to build some of these and it'll start to make sense, right? So once I say new student, it goes and it runs this, and then it comes back, and then here's the point, right? So STU is a bucket, right? And it's going to put the space in memory where this is created into that bucket.
All right.
So now in this program in school, now later on, if I say STU somewhere else, it's going to know who I'm talking about.
All right.
Okay? Does that make sense? Yeah.
Yeah, so on the right, the top line, that's the constructor, just that word.
Yep. This is a constructor.
Oh, that's the constructor.
This is a constructor. This is a call, right? This is where I'm. It's like they use fancy terms in programming to make it sound. I am instantiating a new object, right? I'm making an instance.
So, okay. So then the line above the constructor.
This is the class. That's like this is I'm building the class.
But then why are there parentheses? Did you say there are?
Oh my God!
Okay.
How do you know?
Good call. Good call. Good catch.
It's a joke.
I did, but I'll do it again because it can be sort of a difficult thing to.
Can you go through the quiz with us?
You what? No, I'm not going to go through the quiz with you. I want you to know the topics.
Wait, we go over like the method, yeah.
Yeah.
I feel like the structure.
Okay. Well, a constructor is just a specialized method, right? But it's going to be the same. So here's what. Here, let me do it this way. So if we go in, this is what's happening with the constructor, right? So when I call this, notice that there are parentheses after the student. So that means that I'm calling that method, right? That which is a constructor. Okay? No clue why that happened. Okay? So when I say, if I use the keyword, right, new, and then I say student, this is calling the constructor, right? This will call the constructor. Okay? So I mean, again, some of this you've just got to memorize because it's sort of hard to get your mind around, but it is, when you first run a program, you need to have stuff happen, right? But you have to call that within a method. It has to be within a method. And so the constructor gives you an easy way to call it. Okay? So let me do this way, right? Let me actually here, let's do this. Okay, I'm going to fire up Eclipse. Oh, I see it. Drawing. So I'm going to fire up Eclipse, and we'll look at that real quickly, okay? I'll have this so we can run some code. Do I want to? We'll let that run in the background. We'll look at this, and if we can't get there, we'll do it this way. I'm going to add an extra file here. Let's do this. So if I was going to build a class, right? Let's say I have a let's see. Let's say I have a game class and a player class, right? And in the game, right, I want to in the game class, I want to call, actually, let's do it the way we really do it. So we have a game class, right? And then we have a player class. Okay? And so over here I have a controller. Remember we talked about having like one file that controls everything? So let's say I start this and I want to have a player and I want to have a game and I want to have a player. So remember that the first thing it's going to look for is public static void main method, right? So we're going to have our main method, do some stuff in here, whatever. So public static void main, right? So this is going to be my main method. It's the first thing that runs, right? So immediately I want to start a game and I want to start a player, right? So I say new game, right? And that will start a game. That will go over here and it will build a game. Does that make sense? And then I say new player. Now I have a game and a player, right? So that those two things now exist. What's the problem? Everybody spot the problem? What if I want to say, player make move down here or later on? I can't because I don't have a variable here. I just made these things, but they're not referenced anywhere, so I can't refer to this now. So what I would have to do, right, is go game G equals new game and player P equals new player. Okay? So now I have a game, I have a game and I have a player, right? You following me so far? So then the constructor, when I come over here and if I run the constructor, right, in this we would have public game. Okay, and then in here I would say maybe score equals 0, right? You with me? And then up here I'd have score. Okay? So now I'm setting the value of score to 0 in the constructor. It's where you make those initial values, you give the initial value to one of your variables. Or many of them. You with me? Now the reason that you have a constructor is because it might really be necessary for me to go out, and talk to a database to find out who the player is to see if they already have a score. Maybe it's a game that they paused and then they came back to. Right? You with me? Okay. So I'm setting those values there. So now I can do those things. So if there was a method in here called, I don't know, change position or something, right? Where they're like you're on one place in the field or whatever. If I have this, then now I can say G dot change position. Okay? So this is a method call, right? You see how very similar it looks to this? Right? Parentheses, the name of the thing, and the parentheses. The only difference is that because it's not in a constructor, I have to call it on an instance of that class. So G, what kind of variable does G contain? A game. Right? So it has a reference to a game in it. So I'm saying on this game that you built up here, right, change the position. Like, change the, I don't know, whatever, right? And then player could do the same thing, right? We could go through this whole thing with player as well. I think we're going to get lost in the weeds if we do that. But a constructor is a specialized method that builds the initial values, right? It's the first thing that happens when you build a new class, when you instantiate a new object, right? Okay? And then methods are actions or any other actions that's going to take. But we know that you have to have a constructor, right? Because you have to build the thing to begin with.
Wait,
Yeah.
so the changing of position would be another method?
Yeah. Yeah. Right? And because I called it over here, it would have to be positive, right? Or it would have to be public.
Yeah.
Right? So this would really look like public. What kind of data am I going to get back if they're just moving positions? Void, right? Yeah. Right? So public void change position. There you go. Yeah.
So that's the method, right?
Uh-huh.
It usually involves like public or private, and then
Always it's going to involve public or private. If you don't add public or private, it's going to set it to public. Right? But I will take points off.
And then so like what's the name of that? Like when you can choose either void, integer, or double.
This is the return type.
Oh yeah.
Right? It's what, and you can choose more than that, right?
Yeah.
What if I wanted to know which player, if the game needed to know which player was playing, right? So I might have over here, get current player, right? And then in this, right, so let me do what we would do, right? Public, and then what's my data type? What am I going to get? What kind of information am I going to get? Or object? It could be a player, because that's what's being held in that data, right? Okay, so it could be any kind of information, any object or any primitive data. It could be anything that you include in that. Okay, but for the beginning, you're going to see int, double, string, void, Boolean, right? What's a Boolean? True, false. Good. All right. Other questions? I know y'all don't feel settled with this, and I understand. Are you capable, or will you be capable tomorrow of writing a method without the code inside it? But like if I say, write a method that returns a player's score. No? All right. Let's look at what that would look like, right? Write a method that returns a player's score. So it needs to go from another class, right? Because it's going to be getting their score. So it's going to be public. Okay. What am I going to be? What kind of data is the score likely to be? Let's name it.
Score.
Okay. Get score. No what?
Do you need a cell?
Okay. So, curly braces define blocks of code. Okay? This defines a block of code. Right? This, like anything else, is a statement. So, semicolons go after statements. Right? So, X equals Y, semicolon. Right? A for loop, no semicolon. At the end of a method, no semicolon. Right? It's only for a statement, because this is defining a block of code, right? Okay? Questions?
Get score the class. Like, what do you call that again?
This is the name of the method,
Okay.
right? So this would probably be in, actually here, let's just do it so we can see it, right? This would probably be in public class, right? That's a lowercase c, class player. Right? Now, if I'm building the class, if I say to you build a class, you're gonna write what? Public class player. Then what? Tricky. You don't have parentheses for a class, right? Those are things you just got to memorize. And then where would the end of that curly brace go?
Down there at the very end.
Okay. Yeah.
So the player in that situation would be like, you name it, is that the object?
That is an object, right? So somewhere else in the game class, I might name him, player 1 or P1 or something, right? Yeah.
So if you were to use the double data type for the get score,
Yeah.
and then it didn't have any like decimals in the score, would that change it?
Yeah. So if you tried to return 1, right? You'd get an error, right?
So doubles have to have decimals.
Right. But if you then it would, if that was a double.
Wait, so where would you go if you have to make the class public or private?
Classes are always going to be public for now. Really, it's very rare you would ever make a class.
So then, what's private when you make it?
It means you can't. It means don't worry about. Always put public class and then the name of the class. Just always do that. Okay. Yeah. How many of y'all are still like scale of 1 to 10? How lost are we? Like 10 is. I know exactly where I'm going.
7.
So we say 25? 6.5. It's like 25. Wow. Well done. Okay. You want to go on? And then at the end of class, you all have questions and come back to them? Okay? All right. What's next? Maybe that. So encapsulation, we've already really talked about. Are y'all interested, or do you have questions about encapsulation?
Or is that just public?
Public or private? Right? Literally encapsulate, put it in a capsule, or take it out. Right? Lock it up in a capsule, take it out.
So
Private.
what would we have to do with that? Like,
If I gave you a method and I said, if get score was if the method get score in the player class was called or needed to be called by another method, by another class, what would its encapsulation layer be? Public, right? Okay. All right. Questions? Are we comfortable with the structure and method yet? Did we talk? I know. Actually, let me go back to that thing. Here, let's. All right. Here's a method, right? This is the sort of the fullness of the method. Now, there's a lot of stuff on here, so we can sort of work at it as we go. But what's really important, right, is that you have these pieces of this. Now, there's a couple things I want to point out. When you look up here, notice that this is named the same thing. Did we talk about this already? Did we talk about method signature? Okay, just vaguely, but let me. I'm having y'all are always going to have to remind me if I've covered something if I say it twice because I've just taught 2 other classes of this. So, oh my gosh, I think I just said that. So if I do this, public int get grade, right? There is a signature is going to be the return type, the name of the method, and what the values are, what parameters you call Okay? And again, you just have to memorize it. If you don't understand why, you just have to memorize it. But I'll try to explain. I need to know, like Java doesn't really care so much about the name, right? It cares about the full thing. And so this helps like shape it. Is it possible that if I said divide or like add two numbers or add scores, like maybe you need a double or maybe you need an integer, right? So, well, let me just say this. Think about it like a fingerprint. There are three pieces to a method's fingerprint. It's return type, which is where? Where do you see the return type?
On there?
Yeah.
After the calculation.
What?
After being public or private.
Yep, right. So this is the return type. So I have the return type, the name, and the parameters. Now do you notice that this one's named the same? This name is the same? But it has a different signature. The return type's the same, the name is the same, but the parameters are different. Right? Yeah.
Can we go over parameters again? Like, I know where it is. I know I see it.
Let me show you right here, and then we'll kind of walk through it. Okay. So imagine if I go to your counselor, right, and I say to your counselor, hey, give me the students' grades, right? Give me a grade. The counselor pull up immediately, like just by default, give me the grades for all of their classes, right? What if that's like more information than I want, and I'm just like curious what your grade is for 5th period, right? Let's say instead of just saying give me the grade, I would say give me the grade for 5th period, right? So it can specify more information. So that's what we see here. This get grade, I'm asking for a specific ID. So give me an ID for a specific course, okay? Or specific period, whatever. This one I'm saying give me them all, okay? All right. So a parameter is any information that you need to accomplish the task of the method, right? The method's task.
It's like specialized.
Yeah, I mean, so for instance, let me say like, actually here, I think the next one will, and then I'll come back to this. All right, so let's look at this as an example. Okay, here is an example of a method, right? Get R. Okay, if it's really written out, it would look like this, right? Public int get R, and then a value, okay, or an integer. So what I'm really doing here is I'm saying give me a random number, okay? But I don't just want any random number, right? That could be 2 quadrillion, right? Maybe that's a little more than I intended, okay? So instead, I want to set a maximum. So give me a maximum. So the way that so this is the cycle of a method, right? I call the method. So over here, this is another class, and I say x equals 10 plus get R 10. What I'm doing here is I'm saying, so the computer goes in and it goes, okay, I'm going to set the value to x to whatever happens over here. It starts trying to process this and then goes, oh, wait a minute, I can't, this is another method, right? I got to go do this before I can give you a result. So it goes over to the method and it starts running it. This value is a value that I pass in. I give that method for it to be able to do its job correctly, okay? It could be an integer, it could be a double, it could be a string, it could be anything, right? Basically all I'm doing is saying, look, you need, before that method can do it, what it needs to do, it needs this information. So, maximum value, it goes in, it runs this code, and it returns whatever the number is that, the random number that it came up with, right? In this case, 3, right? So, I give it this number, I pass it this number in the parameters, okay? So, literally, like pass parameter, if you want to hold on to those two, people do that. But basically, it's the information that when you call a method, you need to give it for it to do its job, okay? Then it runs through the process, and then it gives you something back, which is the return, right? The return value. So here, the random number that we found was 3, right? So that 3 then goes up and fills in where it was called. So this method is now becomes the value that it returns, right? So what is now the new value of x? What information I give back?
3.
So x plus 10, or x equals 10 plus whatever result we get from that. So what result did we get? 3. So it's x equals 10 plus 3. Right? So there. Okay? So the parameter is any information that we give in, any information that goes when you call a method. Okay? And then the return is what you get when it comes back. Right? So it's important to keep in mind your method signature is these 3 things. The return type, the name, and the parameters you pass in. Okay? If I were to do this, right, so if I have this, and then if I were to do p, let's do public int, now what am I doing? Right, so within a range, right? Not just from 0. Is this the same? Does this have the same signature as this one? No, because it has more parameters that you have to pass in, right? Good. I know it's hot in here. I either have it, it's like boiling hot or freezing cold. And then lunch. It's always right after lunch because y'all carb load like at lunch. Let me eat like all the yellow food.
Some of it is things.
Ish. I had nuggets today, but I swear they had a green tint to them. Okay.
How does get R know what minimum is? How does it know what minimum is?
Okay. So guys, this is the thing. This is like here's a terrible thing with computer programming, right? Is that once you get these things, they just fall into place. You're like, okay. That whenever that method is called, what I'm doing here is remember that when you're writing methods, that's part of the contract of the class, right? Like this is the way that this thing is going to happen. So if I say public int get R min and max, then what I'm saying is this code can't run unless you give me a minimum number and a maximum number, and that value is decided by whomever calls that method.
Well, yeah, but like, how does it know what min and max is?
Because when I call that over here, so like here I did get R with 10. So what do you tell me? What do you want get R to be? What's the minimum?
20.
20? What's the maximum?
30.
If I call this method, I have decided what values are going to go in the minimum and maximum. This is the contract. I can't do anything unless you give me these 2 numbers. This is you saying, okay, fine, here's the minimum and the maximum.
But how does it know what those numbers are? Like, why doesn't it just take that as it's 20 and 30? What is that? Even though you said.
Oh, because well, so in
so
here,
you have to define in min and max.
because that would be the code in here.
Oh, okay.
I would then say, there's a I can show you if you want, but there's actually like a random number generator that you can actually do this. So you say like, here's the floor, here's the maximum, right? Nick or Duncan, one of y'all write that on the board? Give me do the math random. Nick! Actually, Nick's done it like 3 times without meaning to. Will you write over here, will you write the math, like the code for this? The random number within a range. All right? So he'll write that up, and then you can see like what that would look like, right? It's probably going to confuse you more than anything, but just know that you give the values when you call it, and when you write the method, you're defining what you want. Like you're the creator, and you're saying, okay, if you ever want to use me, if you ever want to use this action, you have to give me some data first, right? And I can't do it until you give me that data, and then that's the data that you use. So you're the one that figures out how you use the data you ask for. It'll make more sense this time. I promise. All right. Another question?
No.
Oh, you're just. All right. I know I'm losing y'all guys. I know this is tough. The good news is, the quiz is tomorrow. Once it's over, right? It's over. And you'll have it. You'll have. You know, you're not at the end of the road. Here's the thing. So let's talk about where we are before we move forward with this, right? So, right now, I want you to memorize the intent of those things, right? I am not going to ask you to do advanced coding and call this method and do that. I'm going to ask you about the form, right? Remember that the point of this quiz is for you to understand the basic building blocks. You're not using them yet, but I need you to know the definition, what a class is. What does a class look like in code, right? What a method is, what a method looks like in code, right? When you see the name, when all of a sudden in some code you see two methods with the exact same names, right? I don't want you to go like, that's confusing. I want you to go, oh, they have different parameters. So it's okay. It's a different fingerprint, right? Yeah.
So in terms of like knowing how to write the form, that would just concern like method, constructor, class, method signature. That would be the big ones.
Yeah, so I might ask you to write a method that has two implementations, like one without. Like I might ask you to do something like this, right? Where you have a maximum and then this one. Does that make sense?
Yeah.
So I might ask you hey, if you had to do this one within a range and one just any random number, what would the method signature be? Okay? So this is all about understanding those basics. So like binary, Booleans. Let me cover that real quick because I know y'all are about to go, right? 7 minutes? Yeah, okay. That should be enough time. All right. So let's look at, the last thing I really want us to look at are variables. Okay. So let's talk about variables. You have at its core, you have two types of variables. So you're ready to go. Because this last bit, this is important. This one we need to hang on to. Okay? We're all up. We're all fighting the carb load. Not yet. All right? You get to pass this time. All right, so we have two types, right? So we have primitive and reference variables. And let me talk to you about what that means, right? If you think about a number, right? So how a computer works, right? You have a processor, a CPU, right? And it reaches out to short-term memory, random access memory, right? And that always has to be on. It's actually really expensive, right? To both run and like resource-wise and also just the cost of the product. So random access memory we have less of, right? And then we have a huge hard drive somewhere else. Okay? Now, if a program has to make a round trip to the hard drive, it takes a lot longer. There's a lot more steps involved. Okay? So you want to keep as much data as you can in random access memory, and that stuff that you can get to really quickly. It's like always on. You know where it is. But there's a problem. I can put a number in here, right? Even if I have 32, billions and billions of bits in my random access memory, it can start adding up fast. Like a 32-bit integer, not bad, right? It's just 32 ones and zeros. I can keep that in local memory. So when I say x, if I say x is equal to 10, right? 10 is just right? That's 10. And then 32 0 or 24 zeros that way. Okay? That's easy. I can just literally put that in the bucket, right? And it's like, I know that I'm just going to keep this. So whenever I refer to x, literally the value that's held in x is 10. Okay? That's no big deal. You can do that for ints. You can do it for doubles. You can certainly do it for a bit, right? Which is just 1 or a 0, right? But a string, right? So let's say that we're doing some work with novels. And so I go, hey, I want to set this string MB, right? Or MD, rather, it would be, right? Is Moby Dick, like the entire novel. I don't know if any of y'all have tried to tackle Moby Dick. It is an incredibly long novel. Okay, and painful. It's like 40 pages. It's just like what whale stomachs look like. Horrible. Okay, but that's a lot, right? What would happen if I stored that in random access memory? It would get bogged down. It would get really slow. It wouldn't work. So listen. So the way a reference variable works is when I say, hey, I want you to set this, it goes and it puts that in the hard drive where you have a lot of memory, right? Listen, I want y'all to see this. It puts this in memory, then it comes over and it stores, so it puts it in on the hard drive at a certain location, at a certain address, and then it takes that address and puts it in the bucket, right? So now I know if I need access to that, right? So I can say, mb.length, which is a method of the string class. I can say mb.length. It's going to go look for the address, go get the data, do what it needs to do, and then get it out of short-term memory, right? So any reference variable is one that is too big to be stored in local memory or has the potential to be too big to be stored in local memory. And then I can go back and I can reference it, right? I'm literally saying, like, I need to know where this is. Oh, it's at this address, and then I can go get it, right? The analogy is you guys with lockers. You don't carry all of your books around because there's too many. So you use the one that you need, right? And then when you need a new one, you know the locker address. You go get it, open it up, get the new book out, and then keep that until you don't need it anymore, right? Okay? So a primitive means it is like the actual value is held in the variable. A reference means it is the variable holds a reference to the data. Okay? Other questions?
Do variables need private?
Yes, they do.
All of them?
No, not all. So remember when you're doing this, if I have a public class student, what am I doing, dude? So listen, if I'm doing this, and I have instance variables, listen everybody, I want you to remember this, right? Instance variables are the variables that belong to the class, right? These need private or public, right? So private GPA, right? Private double GPA, okay? These instance variables need to have private. Local variables, so if inside a method, if I declare a variable, you don't need it, okay? But we're not going to be dealing with that tomorrow. But yes, instance variables need to have public private.
So
Okay.
variables not in a method.
Yeah, that's a good way to think of it. If it's declared outside. All right, questions? How nervous are we? We okay? Or? Slightly nervous? I'm sure it'll be fine.
Everyone fails when we round this up, or is it just going to be everyone fails?
Well, I never say that ahead of time. I want to look and see where we are.
So I made this today just to, as like a demonstration. I'm not saying